Hello. Today I just want to discuss about basic difference between the 3G and GSM. So we'll see what is the difference between 3G means WCDMA. Yeah, that's what. We'll discuss about difference between WCDMA versus GSM. So as we know that the WCDMA is based on CDMA technology. So here we are on a same frequency at the same time. So we are on the same frequency, same time with the different code. The different codes, right? So it is like we are in the one room, right? So we are on the same frequency, and at the same time we all are the user here, and we are operating on the same frequency at the same time, but everybody has a different code, right? Everybody has a different language. So let's say this is the base station. So we are talking to this base station, and base station has assigned the different frequency to different users. So let me put the different color. So these different colors are showing the different codes or different languages. Okay, right? So you can see every user has their own different codes, and these all codes or these all colors are, we call it as a orthogonal codes. What is the meaning of orthogonal? Orthogonal means those channels are unique. Unique means they are not interfering each other. Okay, so they are not interfering each other. Means this yellow color and this orange color, they are orthogonals, So let's take the example. I mean, if this one color is representing, let's say this blue color is English, this other color is, let's say, Italian, right? Other color is French. So you can see those language are orthogonal, because if you know the French and if you don't know the English, you cannot understand what message is going on or what the people are talking on the English language, right? So we are on the same room, and there is one user is talking to the base station in the language of English. One other user is talking to the base station in the language of French. When the French is talking, then the English person cannot understand that what he is talking, right? And when the Italian is speaking, then the English and French cannot understand what is happening on the Italian language, right? So that is how it works. I mean, so we are in the same room, we are talking to the one base station, and the base station has assigned everybody the different language. So that is what we call it as orthogonal codes, right? So we will see that what is orthogonal code and what is the length of those code, and for different services we have to go for a different kind of length of the codes. We will talk about that. Now if you compare with the WCDMA versus GSM, in GSM we are on a different frequency, because you know that the one frequency is 200 kilohertz bandwidth, right? Where in case of WCDMA it is 5 megahertz, so it is quite wide band, right? That is why we sometimes we call it as a wide band also, right? So here you can see we are on a different frequency. We have certain megahertz on 900 or 1800. We divide them into 200 kilohertz and we call it as a one channel, right? So this is one channel, is 200 kilohertz. So this is what we done is FDMA, right? So this is FDMA, and then in one channel we again split them to 8 time slots, right? So that 8 time slot is, we call it as a TDMA, right? So what is happened, I mean, like in GSM, we have a big room, let's say 900 megahertz. We have 25 megahertz is a total band available in 900 megahertz. And in this we again divide this the big room into small rooms, right? So you can see that this is all small room, and size of each room is 200 kilohertz. And now for this small room, this is small room here, this room we are asking 8 user to share this room, so at a time only one user go inside. So user 1 will go inside, right, and then he will be out, and then user 2 will go inside, then he will be out, right? So we can share this room with the 8 users. So 8 users are going to share this room. So at a time in one room there is only one user is going to be, so it is not going to be all user at the same time. So there will be one user in the 200 kilohertz frequency, right? He will stay only for some time. You know how much it is? 577 microsecond. So this is the only small time he will stay there, and after that he has to rotate this, the chance to the other user, right? So you can see that the major difference between WCDMA and GSM is the technology. I mean, the modulation got changed, right? Here you can see we are talking about WCDMA, right? Anyway, WCDMA is a is air interference air interface technology which we use for 3G, where the GSM we use for 2G, right? Okay, so that is a major difference. I mean, you need to understand this two difference. And here is a 5 megahertz, here is a 200 kilohertz. Okay, let us see what else the difference between them. Other thing you understand now, I mean, in WCDMA we are in the one room, right? WCDMA, and we are talking to one of the base station or one of the cell, and we are at the different location, right? So you can understand we all are talking at the same time to the base station. We are all are talking the same time. So here we are talking same time in a room. So you can understand, I mean, everybody is on a same frequency, same time. So it is going to generate a lot of interference, right? And to minimize the interference, the power control is the most important in WCDMA. So now what we are doing in 3G, I mean, we are changing the power in uplink as well as in downlink. Downlink means for the base station for specific user, and for uplink is from the mobile to the base station, right? So that is the MS. So power control, we are doing power control 1500 times per second. So you can understand that it's very aggressive, right? You have to reduce the power so that you don't interfere others. Otherwise, although they are the different language, they are in the different codes, but end of the day you are in the same room. So sometimes if I don't understand the German, or if I don't understand the Italian, but they are talking too much, with the high volume, it definitely creates a lot of noise for me. Excuse me. So that is why the power control is most crucial in 3G, and that's why it keep it around 1500 times in 1 second. Where in case of GSM, right, as you know, in GSM in one room we just go, one user go and then come out. When you go inside, this is one room, you have enough wall, this is a small room, but you have an adjacent room, but that is quite far, and you have enough room inside, enough room wall between them. So whenever you go inside, you can shout as loud as possible. It is always good that you should only talk as you keep your volume as less as possible, so that you don't interfere to other people. But anyway, even though, let's say if you go and then you transmit the high power, or you don't transmit the optimal power, even though it is still, I mean, manageable. Okay, so you can see that the power control in GSM is, we can control the power every one Sech block. So Sech block, you know that one Sech is 480 millisecond. So I can say every 480 millisecond I can ask mobile to increase, decrease, or I can ask BTS to increase and decrease power as per the requirement. So I can say, oh, 480 milliseconds is very near to 500 milliseconds, so 2 times in a second I can control the power, right? So as you know, the GSM, it's not so aggressive power control is required, as everybody is having enough isolation between the two different rooms, and in one room we just go only one time one user, where in case of WCDMA you can understand that we all are in the same room. Somebody are very far from the base station, somebody are very close to the base station. So if you are close, you should transmit your power as low as possible. If you are far, you need to transmit your power high as possible, just to reach your voice to the base station. Here in the WCDMA means your voice has to be as low as possible, whether you are far or near, right? If you are near, for example, if you are near and you are shouting too high, then somebody is quite far and he wanted to send the voice to the base station, it is not possible. As you know, your voice from here, it will reach very weaker here, and somebody is very close to you, right? And this guy is shouting too much. So because of the near user transmitting high power, the near user is transmitting high power, then the far user will suffer. So that problem is quite well known in CDMA technology, is the near far problem. You can search in Google and you can you know learn more about it, and this can be avoided only the help of the power control. Okay, I'll talk more about other differences in the next video. Thanks.